Good morning, good afternoon, bonjour, buenos dias. Welcome to this section of our virtual tech day. I apologize if this introduction is a repetition of our earlier session, but we do have new people joining. So we've got participants from all over the world. So we're hoping we won't have any technical issues, given that everybody is using the internet at the same time these days. So we are not going to do a video meeting, one, to avoid some Zoom bombing, and two, we don't want to scare anybody because certainly on this side, we look like wild animals because we are overdue for our hairdressing appointments. So a few housekeeping issues before we get started. If you have any questions, please feel free to use the chat box and we will answer your questions either during the meeting or during our Q&A session later on in the session. We are repeating this event next Wednesday, April 29th, same time, same topics. So if for some reason you have to leave, please join us on the 29th. Or if you think any of your colleagues could benefit from participating, please forward to them. So we'll be sending out a recording to all participants after the meeting. And without further ado, let me do, quick introductions. So my name is Anne. I'm in charge of operations for North America. We have David, Frank, Marco, and Justin. And Frank is our subject matter expert on file size reduction, and he's going to be doing the presentation in conjunction with Justin. So Justin, I'm going to hand it over to you. Thank you very much.
Thank you, Anne. So from our poll, a very large margin are looking for creating lightweight models, file size reduction. A few other use cases that had quite a bit of votes was preprocessing for AR/VR packaging, and protection of IP, with decimation falling the shortest. So I want to get into this webinar. I'm not going to take up too much of your guys' time. I want you guys to really actually see the technology. So in today, we've already gone through introductions. I'll give a brief corporate overview, and then we'll get straight into the live demo. During the live demo, I do have a couple more poll questions just to kind of get a good rough idea of what the attendees are looking for. And so as you can see here, these are our current and past customers across the globe. I know when you look at this slide, you probably automatically see a few logos that immediately stick out to you. We have been in the business for over 20 years, and we have 4 main products. 3 are actually software products, and 1 is a reading library. So the reading library is we call it our kernel IO. This is embedded in softwares that you may have already used in the past, such as Alter Engineering, Beta CAE, MSC software. When you actually click File Open, you're using CoreTechnologies reading libraries. And what makes those libraries so unique is the fact that we do not need access to the native API to read a fully parametric model from that API. So for instance, the CATIA model, you don't even need CATIA on your system to read that CATIA model in our software. And so we've embedded those libraries in our 3 tools today. Today you will be seeing 3D Evolution, so I won't touch too much on that. But within 3D Evolution, a couple other things that we offer is file conversion. We actually have the ability to heal models for your target system. And then we have a couple FEM tools that you'll kind of see in this presentation as I go forward. We also have a 3D Analyzer tool. This is our visualization tool, and we are actually having a presentation in a class on this. After this one. Following this one, I will put in the chat the registration link, so if you haven't registered already, you'll be able to register for that. Within this tool, we really have the ability to analyze the data. And furthermore, what's nice is it's a fairly inexpensive solution, and we still have our library, so you're able to read in any file format that you would like and analyze that data and do different things like model comparison, thickness checker, backlash detection, things of that nature. And then from our class earlier today, we covered our 4D additive, and we will be covering that again next Wednesday. And this tool really allows you to pre-process your data for additive manufacturing. And in doing so, we've kind of trickled our technology down from 3D evolution and really tailored it to the additive manufacturing space. So we're able to still heal data, but within the 4D additive, we're working with the boundary representation data and not a tessellated model. So it allows us to be very accurate, and then we also have a texturing tool, which is best in class. So why this technology is helpful, what it does, and what are the benefits. So throughout this presentation, and what I would like for you to take from this class today would be to know how companies are leveraging our solutions to automate their engineering chores. And so within our simplification solution, it's very, very customizable for your requirements. And furthermore, it's customizable to automate those chores for your requirements and still get the same output that you're looking for. These are the file formats that we read and write to. And again, we do not need access to the API to do that. So you'll see all the major formats on there. And so throughout this presentation and during Frank's demo, you'll probably hear a few different terminology, and so I just wanted to briefly touch on this. So for simplification, what does that mean to us? So to simplification to CoreTechnologie, that is the removal of internal components and creating filled solids. We also have a tool called shrink wrap. Now, if you're familiar with Creo, you've heard this term shrink wrap before, but you automatically probably assume a tessellated model. So we do have the ability to shrink wrap for tessellation, but furthermore, we have the ability to shrink wrap to assist with our simplification. And in doing so, we can detect inside and outside bodies, which you will see today in the demonstration. Another really handy tool is our bounding shapes. This allows us to just make an overall shape of an entity. And in doing so, it drastically reduces size, which you'll see a few examples from, and it also protects your IP. And then we have complementary FEM tools available as well to remove chamfers, fillets, create metafaces, and I will touch on that some more. So I really like this slide because this kind of shows you like the life cycle of the simplification process. And again, this is all tailored towards your requirements. So as you can see here, we have the original model starting at 142 megs, and after running simplification, putting some bounding shapes on it, and then shrink wrapping it for tessellation, we have got that 142 meg file down to 0.4 megs. So in a drastic amount of file size reduction, as well as it is quick. That is one thing to point out. Everything you're going to see today is able to be batch processed, and you will actually see how to automate these processes in the demonstration, so I won't touch too much on that. And as I stated before, geometry simplification, a couple of use cases, IP protection, lightweight models, pre-processing your data for AR, VR. With our simplification solution, we have the ability to do core extraction, which could come in handy and save a lot of time. And so one thing that you won't be able to see in detail today in the demo, just in the essence of time, is our level of detail. So Frank will probably touch on this in the demonstration, but I wanted to kind of go over it in more detail here. So for our level of detail, depending on your requirements, we can actually remove the holes. We can keep the holes if maybe they're connection points for your supplier or for yourselves going into your mass assembly. We can keep those points, or we can just deboss them or put outlines on them. So it really tailors to what your specific requirements are and what you want to do with the holes. So obviously, if we wanted to reduce the most file size, deleting those holes, but sometimes in some situations you can't do that. So we have other ways to assist with that process to still eliminate file size, but reach your required output. Shrink wrap technology, now I touched on this before, so I'm just going to skip over this slide because you're going to see it in the demonstration. So really quick, what you can see is how we can identify external and internal bodies. And then our bounding shapes. So you will see this as well, but this slide is really nice because it kind of gives you an up-close and personal view of what's actually going on. So with our bounding shapes, you can customize the accuracy depending on how much of the part you want it to still look like the part. So sometimes you may just want it to be a box and you don't care what it looks like. So in that sense, obviously you're going to reduce the file size drastically, but you're going to remove a lot of that detail. And so this kind of gives you a process of what it looks like within the accuracy. So you can see at one point it's 4,300 triangles, and then at an accuracy where it's just kind of the bounding shape, still looks like the model, but definitely doesn't have any of the rounds, and you lose all of these different faces, and we've gotten the triangle count down to 56. And so you'll see kind of a better example of this with this model turbo. And so if we want to reduce the polygon count through decimation, we have the ability to do that as well, and we can do that by adjusting the sag. And in adjusting the sag, we're actually adjusting the polygons and how they work. So we can go to the extreme to where a circle now looks like a stop sign, or maybe we can't get to that extreme, but we still want to reduce the polygon count. And as you can see here, we started at 2,300,000 down to 17,000, and it still retains the shape. It's not just a blob on screen. And then, as I spoke earlier, the FEM tools that kind of complement our simplification solution, these tools allow you to, again, remove Phillips chambers, delete holes, create mid-faces, merge faces together, which could help reduce polygon count. And then we have the ability to batch process, which is what I touched on earlier in this presentation. So essentially, this is the goal: send to right click. So if you have your model and you want it to go to simplified shareable, you essentially want to be able to right click on it, tell it to send to simplified shareable, and you want that to grab that model, run that process, and just give you the output. You don't want to have to touch it. You don't want to do any of that manual work. And to give you kind of a brief example of how that would work, so if your model is sitting in your PLM system, you would have it export to your desired files that you need. Then you would define the include-exclude list. So within our tool, you're able to include and exclude specific components, and you can call them out by different attributes, coloring, different pre-processing processes that we have to enable you to include and exclude specific entities. And then you have your batch parameters, so your specific scripts that you're running. So after it runs those scripts, so you have pulled it out of the PLM system, 3D Evolution has now taken that file and run it through our EDM, which you'll see today, ran your batch scripts, give you the exported file, and then in doing so, we can also check that file to see, does this meet your requirements? And if it doesn't, then we would do some manual retouching, which is not too often. But if it does, then we write it out to your desired file format, and then it goes back into your PLM system, and you have completely limited your interactive approach to simplifying that model, or any other things. We can also do it with conversion, different processes. So a few simplification results. So we are used to, and we kind of hold ourselves to a high standard when we simplify a model. And typically we get well over 80% file size reduction, if not over 90% file size reduction. And that really just depends on the customer requirements. So these are a few examples that you can see how that got to where it got, and then how quickly it did. So in 45 minutes on a 550 meg, a half a gig file, 45 minutes running automated, we got 96% file size reduction. And then as you can see down here, we even get 99% in a lot of cases. So I'm going to pass this over to Frank for a live demo. But before I do that, I would like to submit one more poll question. And again, I'll give it about a minute. And then I also see a question. Prasad, so his question is, do you have any plan to integrate your software within PLM such as Teamcenter? So actually, I will let Frank touch on this and explain kind of the process of how we can do that. We have implemented our solution into Teamcenter before, and Frank has previous experience working with Teamcenter and 3D Evolution. So I'll let Frank kind of answer that question.
Thank you for that, Justin. I really appreciate it. Yeah, Prasad, so what I did in my previous role is, I was automating kind of the geometry simplification processes for a company that would supply the engineering models, but as a simplified representation on a dealer-facing website. So that dealer could now take in that model and put it into their application. But how we controlled the whole process was through Teamcenter. So we actually added a tab into the top where you saw where it said the right-click solution said Simplify Shareable. Well, we actually had the Simplify Shareable tab inside of Team Center where if you have the item selected, you go up there, select that tab, choose the level of detail. So what's really interesting is we can have a couple different customized scripts, as in we can have a simplification script specifically for internal use. So then you can have your whole master assembly, but have a lot of simplified models. So then it reduces that file size. Just so the maybe managers who want to visually see some of these representation of these models, they'll have a lighter model to utilize. And then another one we'll create is an external use. So then we'll extremely simplify it down. We'll modify some of the model tree or compress all the bodies into one body. And just so when you export this out, they only see the one body part in the tree, so then they don't have all the nomenclature and everything of the actual engineering part names and things like that. So, and then the third use case mainly was for like the pre-processing for AR, VR. So just basically producing one of those simplified representation models to where now an AR, VR application can grab that model, do the optimized decimation on it for the specific application it's going to. So hopefully that answers your question, but yes, there's different details that we have implemented inside Team Center with multiple script options depending on the end consumer.
And tailored back to your question, this is David, is we can either complete that task with you or we can complete that task for you in implementing it into any PLM system.
Perfect. Appreciate that, David. So as we talk about this and go through the different steps, what I wanted to explain is, we can create these outer shell geometries, and then we can control the level of detail based on the end consumer. So for this example, all I'm going to do is just show our simplified bodies. So what we want to do is remove all those internal details and maybe even keep a specific hole or something like that. So maybe just one hole that we want to keep. So I'm going to select this face. And as everything that you see me do interactively, this can also be done as a batch process. So what I'm going to do is I'm going to keep this one hole, and then everything else is just going to be simplified. So now if I hit section cut, so now you see you got your thin outer shell model, but everything internally is gone. So what this does is it might not be your 90% reduction every time. Sometimes it might only be 50% reduction. But when you have 100 of these, and now you already reduced the size in half, and you're added on top of 100 to maybe a couple thousand other components, when you do that across the board, it really drastically reduces the file size, especially when you get into larger assemblies, because we can remove specific components and things like that. So the same thing for this block. So you see, so if I hit this mesh view, you can see how complex it is as you see all the different lines it creates. So it's an extremely complex model. So maybe you actually manufacture these blocks, but sending out to a customer who actually builds the whole engine assembly, but you don't want to see how all internals are made within the block itself. So what you can do is when you go through and do the same thing, you simplify the bodies. It's going to remove all the internal detail and drastically reduce that file size for the end result. So what this thing started off is about 75 megabytes. We got it down to under 15 megabytes. So just a little over like 70% reduction just off of one click. So when you go through and drastically do this through a lot of your components, it actually helps tremendously on the end results. So that's just showing just kind of how you can simplify the geometry and getting rid of all the entities that are proprietary to what you want to keep in-house. So as Justin touched on, we also have our shrink wrap for simplification. So we have the ability to detect internal and external bodies. So we can create a shrink wrap of this model, or I just say I want to detect all the outside bodies. I'm going to leave it at the default voxel size, and then we're going to execute this. So the voxel size is almost like a cubic pixel. So when you're saying that you have a larger voxel size, it's going to skip over a little bit larger gaps. When you have a smaller voxel size, it'll actually dig into some of those gaps and grab some of those internal components, kind of depending on how the assembly was set up. But what our developers done is kind of optimize based on the model size, and usually the 1% works just fine, but we can always justify that if need be. Like if you're seeing certain components being removed that you don't want removed. So I'm gonna do a section cut real quick. So as you can see, we have all of our internals gone. So if I switch this to my internal bodies filter, so you see you have your engine compartment, you have your exhaust housing, you have all the important details that internally at your facility you will need, but when you ship these out or you're trying to create a plant layout or things like that, this drastically reduces that file size. So just to show you what it looks like, the original file size is about 145 megabytes. And when you export it out, so when I save it out just these external bodies, it goes from that 145 down to 23, and that's without simplifying any geometry. And then now when you take the bounding shapes, so now if what I could do is I could simplify. So I'm going to go ahead and delete all these visible objects right now. Get rid of my section cut. So delete all visible since I have all the internal right now shown.
Frank, this is a good time to ask. We have a question. After simplifying, are you able to transform the assembly to where it's one part, one body, or are you kind of stuck with what you get?
Yeah, so we have a couple of different ways to do that. We have where we can kind of trick the systems to say we want to just merge the model tree into one body. So if I have all this over here and then I say I want to flatten the assembly, so you just transform it, you flatten it, so that'll make it a one part at the top with multiple bodies underneath of it. So every time you see a part in this assembly, it'll turn into just bodies. But then we can actually come into our advanced tools and say I want to merge all those bodies. So then now when you're exporting this out and you're sending it to a customer site, it's only going to show as one body, one part, but it'll still have some of those details that show it's not actually 100% Boolean. But if you want to Boolean all those different parts together, we actually have a Boolean operation tool as well, where you can add specific features to each other, you can minimize them, or you can just like merge faces to combine it all to be one body, one part. So there's a couple of different operations that we can get through and go to kind of get to that one body, one part that some customers are requiring. But for this example, what I'm going to do is I'm going to go ahead and I'm going to simplify all in one step. So what it's going to do is it's going to go through and it's going to fill in all those great holes, fill in any cavities. It's going to basically fill everything. I didn't select anything right now to say keep as mounting points. Just for this example and for the speed, I just wanted to kind of continue going down this route. So it is now this exported file. So just the simplification, so that 145 is now down to 7.8 megabytes. And then when I go through and I say, you know, I want to actually create bounding shapes, so I want to use box and cylinder and polyhedron. So it's going to calculate and look on the volume or the kind of the type of model it is, and it's going to determine based on the optimization which one it wants to create. So now when I go through, it's going to create a bounding shape for each part. And as it does that, and I save that out, so I'll just go ahead and save it. So as it's computing, you'll see the bottom bar at the left, it tends to be pretty accurate on what percentage it's actually at. And then, so now when I want to convert it out, I can choose my file format, say I'm going to go to Parasolid. And then we also have different name restrictions, name lengths, and things like that, and forbidden characters. So as you're doing the export, you can specifically have different names or different model tree structures to kind of match on the requirements based on the internal use or external use, or just on the end consumer itself. So like I said, so when I save that out now, that one file goes down pretty drastically. So now we're at 2 megabytes. So started at 142 down to 2 megabytes on just a couple of different clicks. So this is extremely beneficial when you're doing things like plant layout and things like that. So now that I've done kind of the basis of this, I'm going to take these same techniques now and I'm going to start applying them to like an automated process. So we provide out-of-the-box scripts. And so you can actually just, when you buy our batch processing solution with 3D Evolution, you could just grab the model, send it through our batch or EDM, and just process it that way. But the question is now how can you maybe customize it or build a script? So as I go through this next assembly, I'm going to go through and kind of simplify it and then show you kind of what I would do to essentially build the script itself. So as you can see, we have just a couple like shipping end caps that really don't need to be used because maybe the consumer is actually going to be plumbing up to these different connections. So I'm going to remove those. You can see there's bolts here. I'm going to have those removed during the operation. But then I'm going to simplify everything else. So I'm going to come into my simplification tool. I'm going to say I want to simplify all in one step. So what it's doing is it's simplifying the assembly and simplifying the bodies all kind of in one process. And then I'm going to grab, so if I wanted to say deboss all circular junctions, that's going to say anytime it calculates a hole, it's going to deboss it. And then you can control the height of that deboss, so it automatically defaults to 1 millimeter. If you have holes of certain colors, like all these red holes, we can make it to where the red holes are going to be the only ones that are going to be debossed, and everything else that's a different color can actually be completely filled in. So there's a couple different customized options that we can use with that. Just for this example, I'm just going to go ahead and grab my removals list. So all you need to do is call out the location. So I call it out, and then it's going to go through and simplify the geometry. And then it's also going to remove all the names so when we read in these parts, we can read in all the parameters and attributes that are defined within the CAD system itself. So anytime maybe like a nut bolt washer or that type of nomenclature comes across, it'll automatically be deleted if I add it to that removals list. Or on the contrary, if I have specific flanges or something that I know for a fact are going to be customer connection points, I can actually add those to the exclude list. So now it's going to be excluding it from simplification. So as you can see, if I do a section cut of this, it's got a nice shelled out model, but as you can see, there are actually still some components that are left internally. So this is where I'm going to go ahead and use my shrink wrap algorithm to detect those inside and outside bodies. So as it's going through this, it's doing just by the voxel size like I determined before, and it's just I left it at what I had it on before. So this example I'm using 0.5 because sometimes there's a little bit smaller gaps that if you use a 1, that sometimes it'll actually skip it over. So I'm just using it a little bit smaller on these type of smaller models. So now if I come in and I say I want to see internal bodies. So these are just a couple of pieces that were left over as internal, and then you can easily delete them. So now you're asking, okay, you showed how you did this. Now how are you going to be able to put this into a batch process? So we have something called our shell window. So what this does is it captures every step and module that you just used to create your result. So if I look up through here, it's just showing like this is just an options for showing filters. So I showed the inside bodies. Here's your simplify. So this is where I opened the script for it, the removals list. So so what I'm going to do is I'm going to say, okay, I want to copy this operation all the way from where I opened it to where I simplified it down. And then I'm going to copy into a notepad. So I got this right here. And then what I'll do is I'll come in here and kind of remove some of these different selects. So I got my simplification type. I have my other simplification type. And so there's the open, so I can actually remove all this. So then now what I'll do is I'll save this out. as a session file. So when I save it out as a session file, what it's doing is you're basically creating your own button. So when I come into my little user tools over here, so this is just the option to basically have any commonly used tools. So as we have our different workbenches, you can put all the tools that you use consistently, and then you can also have your session buttons. So if I open this one up, and I look at my simplify, so just make sure kind of all the settings are how I plan on it being, which it'll update with the different script that I have selected. So now I'm going to come in here, so you can see you still have all your internals. It's all back to the normal geometry. So I say crypt command, I'm going to add new, so I add the new session button, and then I'm going to come down here, and you're going to watch it run live. So the same, kind of the similar process that I used before, kind of interactively, now you can do it as an interactive automated process just to see how it will perform as a script itself. So I'm going to go ahead and double click on my 5. So as you see, it's going through the simplification right now. So you'll start to see some parts being removed, like those end caps and things like that. So those removed, the bolts were removed. Now I'm creating minimum bounding shapes. So now it's back to, now it's doing the shrink wrap. So I'm calculating the rest of those internal bodies that were left over.
Frank, I think this is a good time to ask the next question. When doing the simplification, do you want to convert it to your desired file format first, or should you simplify it and then convert it?
So what we like to do is we like to simplify it then convert it, just because, you know, you take out the steps. So when you're trying to optimize the process for automation of geometry simplification, you don't want it to try to include a bunch of different extra steps that's just going to increase the time it takes to process. So like we do have the ability to heal and stitch certain models and make them a solid model. So sometimes when you need this to be a 100% solid model, you'll have some imprecisions and things in the model. Well, if you do a heal and stitch initially, then you're actually adding a process and you're trying to heal and stitch faces that are essentially going to be filled in down the road. So you're actually adding a lot of different processing time. So when you're doing those conversions, we always recommend it to do at the end as like kind of like the last result. So sometimes what I'll do just to get comparison, I'll do an initial conversion, save it out as maybe a step file, because then as I see the resulting file, I can have that simplified rep as a simplified model as well. And then you can do a apples to apples comparison on the file size reduction. So when you talk about, you know, simplifying these models and having different file types, so like this one specifically, the truck engine block. So the initial cat part was about 75 megabytes. When I simplified it back to a cat part, so they can still have it in their PLM system or can have it for the internal use and build a simplified representation that they can still use in their main CAD application, it takes us down all the way down to just under 15 megabytes. So it's really important to understand kind of what requirements you have and what your end goal is. And we help to define that during training and implementation to make sure everyone's on the same page and you're getting the best bang for your buck. So now we want to take that to a lot larger scale. So we have kind of something similar that we'd put into a plant layout. You have your mounting feet down here. So the end goal of this one, what we've done is we've optimized a process for JT files. And what we want to do is we want to keep all the specific mounting points as BREP geometry, so you can have exact representations and exact measurements of where the details are and how it'll mount precisely. And then all the rest of the geometry is just used just for like spatial constraints and just to hold a space in your assembly. We'll convert those all to tessellated. So with our JT open options, we have the ability to do JT tessellation and JTXT BREP. So then when I do convert this out through our automated process, it's going to keep just these mounting feet as BREP geometry, and then everything else can be just a tessellated geometry to get a maximum file size reduction. So when you saw that 99% reduction, 99+% reduction on the slide with the 5 different parts, this is the best way to optimize that type of reduction, because then you can get both simplified tessellation and simplified B-rep geometry. But so what I wanted to do now is I'm going to pull up in my Enterprise Data Manager, and I'm going to show you kind of what it will look like to do the testing on the batch processing. So when you implement this inside a Team Center, or we have that right-click solution, all these different parameters were actually going to be hard-coded, and we set that up during implementation and things like that. But to do some testing and some studies, it's good just to have kind of this all set up and laid out, so then you can completely customize these different boxes to say exactly what you want. So like here, I'm just having parts that I want excluded. Here's parts I want removed. So we can do it between this or between the removal list. I do this kind of for testing per se, just so I can kind of do it on individual components sometimes. And then if you want to create a bounding shape, so for those specific components that aren't completely necessary to have all the detail on, and then I'll add specific components to a layer, and then also I want to remove curves. So what curves are is sometimes we read in all the curves that the engineer used to design the model, and it actually can increase the file size quite a bit just to have all those 2D curves. And so sometimes when you think you're exporting it out, not having those, it actually is saving kind of as a hidden layer, but it's still adding that file size. So we'll just kind of remove those during the process. So when I come in here, I'm going to go ahead and grab my files. So plant layout, and I'll grab this one, okay. And like I said, I've actually wrote a macro that would process 100 to 200 parts at a time, and it would actually fill out all this within all just one Excel macro. So I mean, there's kind of different ways that you can kind of automate different processes, but it was when I was testing the scripts to be put inside a Team Center, I would, instead of having to go through and manually do all this, I would have a macro set up just to kind of fill all this information out for me, and then we'll run it. And so you go to your batch manager, so now you see the job is kicked off. So that's one solution, and we'll show you the results of that one here shortly, because I want to kick off one more job. So we also have a skid loader. So this is where you're kind of pre-processing models for AR, VR. So you have this an entire assembly, and you see once it loads, it's extremely detailed. A lot of detail, a lot of excess stuff that you don't really need, like things maybe in this engine compartment, things like that it's not going to be shown. And then you have like the details in the treads and the tracks and all the cylindrical parts and things like that. So this is all extremely detailed. And when you save this out, the file size is actually about 1.6 gigabytes. So it's extremely large. And then what we'll do is I actually called out a couple specific subassemblies to do different type of operations too. So when I break down these different attachments or optional attachments, so a lot of these, like just the idler configs alone, will have a specific type of minimum bounding shape operation that's going to be a little bit different than, say, the actual like base machine itself. So the base machine, we can keep all the specific details like this for the rounds and everything like that, all the like important exterior components, but then when you see certain things that kind of fall down kind of near the bottom or kind of a little bit hidden but still could be seen down the road, or maybe someone starts hiding a couple layers, they still want to see a couple of those components, but we can have those a little bit further simplified because it's not as critical and not as doesn't need to be as appealing to the eye as all the other components. So there's different ways we can customize this. So when I come in here, come back into my EDM, I'm going to go ahead and process one for this AR, VR. So go and grab my components. Grab my skid. And batch output folder. So this one I'm just going to convert to an FBX. So I want to use JT because I want it separated as tessellated and BREP geometry. And I didn't put any parts to exclude or anything like that, but I have all the nuts, bolts, washers, everything like that. It's not critical to be removed. So the same thing, I'll run this operation, and you'll see it kicks off a job. So when I ran this before, you know, the skid letter a lot larger, a lot more detail, a lot more customization. Took about 44 minutes to process. A little bit smaller, so this is the 100 megabyte plant layout file. It took about 7 minutes to process, and this is about, I think this one was a 250 megabyte file, and it took about 12 minutes, 38 seconds to process. So when I now show you the results of these files, so if I sit and look over this one, so you can see how it shows just like a dotted line with triangles. That's indicating that this is tessellated geometry. So when you look at the file size of this, so what started at 100 megabytes is now down to, as just the BREP alone, so the 100 megabytes went down to 7.5. So it's just like a 92% file size reduction. And then now when you save out the BREP with visualization, so you have your BREP mounting feet down here, and then you have your rest is tessellated, it actually comes from that 100 all the way down to 600 kilobytes. So that's where you get your 99+% file size reduction on specific models like this. And then now when I open up the skid loader, so we have specific operations. So like you can see the tracks I turn into just a very generic like bounding shape. All of the cylinders are very generic, but it still holds the detail necessary. So like when you look inside here, I mean, you still have your armrests, your joysticks. You can see the levers I created as minimum bounding shapes, but you can't really tell. So it's still a lot of detail that looks really good and really clean. So there's just different customization sides that we can kind of get to that maximum file size reduction of your specific type of data set. So when you look at the resulting files of this one, so that 1.6 gigabyte file as a result is all the way down to 113 megabytes. So there's already over a 90% file size reduction in that one. And then when you start processing for AR/VR, now you have a already pre-processed model 100% ready to go and be optimized for the specific application that you're going into. So there's just different areas and different parts that we can customize specific on the end consumer or where it's going to be going and who's going to be utilizing it. So maybe this part right here could also be utilized as internal use. So when someone's trying to show this to the managers, they can still talk about, you know, the different joysticks or the different maybe stereo systems and everything like that can all be put in these and have a couple different option configurations. So when they're seeing it, they have a lot quicker representation on the graphical interface. So they can utilize 3D Evolution or 3D Analyzer, or we can put it back into the native CAD package itself as a simplified representation, so then they can see the resulting file size and the resulting files, and they don't have to worry about the lag, because that 1.6 gigabyte file is extremely slow and hard to use on majority of engineering computers. So that kind of sums up what I was going to cover today. I don't know if there's any specific questions or anything else you'd like me to touch on again or go over a little bit more detail on. But please feel free to ask your questions, and if you'd like to see something over again and do a quick another demo on, please don't hesitate to reach out.
Yeah, there's a question here that we have regarding color. So rather than going through a full large assembly, is there a possibility that I could add an exclude list for specific color in the assembly?
Yes, yeah, definitely. Yeah, so if you already have specific components color coded, we can actually read in. So if I select this specific part, so we read in the colors and we can select it by those specific colors. And we can do operations based on color, based on size, based on part name. So there's different ways we can do different customized options. Like I said, it also comes in with all the attributes and all the mass properties.
And then there's
And then we also have, a feature as well for if you want to do a simplification of a model, we can actually keep the original mass properties. So sometimes you want to put like center of gravity and things like that on your 2D drawings for a customer, but you can't get an accurate 2D or center of gravity based on a simplified representation. We can keep all the original mass properties. So when it computes that center of gravity, you can get the original properties that you need.
That's awesome. There's another question coming in regarding the solid model. So if there's areas or a specific part that I want to keep as a solid model, because I'm using it in computational fluid dynamics, is there a way after it's simplified to create a solid model? Or if I could add to that question, maybe like a core extraction?
Yeah, definitely. Yeah, so we also have the ability to do what's called a core extraction. So when I pull open this turbo again, what was all that detail that I actually removed, we can actually have just that detail left over. So sometimes you need to know and understand what that internal volume is. We can actually calculate that based on what we read in how we have our tool set up. So we have what's called our simplify manually that'll separate each, basically each design feature that was used to create this model. So then I come in here and say, okay, I want all these internal components. I want to keep this. This is going to be for my my air solid, essentially. So you have just a solid model of what the airflow would be inside the turbo, and then you can go through and you can calculate the volume specific on this model. That answer the question?
Yeah, I think that answered the question.
Yeah, so we'll find all the center of gravities, curve length, the moment of inertia. We do all these calculations within our solutions based on the mass property. So if you have all your density and everything filled out specific to that specific component, we can get very accurate numbers based on the data that we have inputted into the system.
I see another question here regarding the ability to create Boolean operations. You had mentioned that. So
Yep.
kind of like a space maybe in that tracker that you showed. Is there a way to calculate that space as well?
Could you ask that one more time?
Yeah, so being able to create a Boolean or the amount of space in a tractor. So if someone's sitting in that tractor, they can detect how much space they have to move around. Is that possible?
Oh, yeah. So if you wanted to essentially try to figure out how much movement you have, maybe if you have a compressor in one of your older tractors or something like that, you can get the overall volume and size and bounding box of this model, and then you'll have essentially almost like a tolerance stack up that you could use to figure out the best location, kind of form and fit for that application.
Very good. Thank you.